When you use a streaming service that accurately guesses the exact movie you want to watch, or ask a chatbot a complex question, it feels effortless. Take a self-driving car navigating seamlessly through a rainy, crowded city street. It is tempting to assume that a team of human engineers manually typed out the instructions for how the machine should behave in every single one of those scenarios. But as you can see in this flowchart, traditional software relies on strict if-then commands. To program a car this way, an engineer would have to write a specific rule for every raindrop, every pedestrian, and every flickering street lamp. The logic branches into millions of conflicting paths and immediately collapses. Rigid, manually written code cannot survive in a highly dynamic, undefined real-world environment. Because of this limitation, these modern systems are not preloaded with hard-coded answers. They are not born intelligent. They have to be taught from scratch. To solve the problem of infinite complexity, engineers stopped giving machines rigid instructions and instead gave them the ability to figure out the rules for themselves. Think about how you teach a 5-year-old child what a cat looks like. You don't hand them a biological checklist of feline anatomy or a rigid set of physical dimensions to memorize. You simply show them pictures. You point out black cats, large cats, and small cats. After seeing enough varied examples, the child's brain naturally extracts the underlying physical traits, allowing them to instantly recognize a new cat they have never seen before. Machine learning is the branch of artificial intelligence where a computer is built to mimic this exact behavior. If an AI studies millions of emails marked as spam, it doesn't need a human to provide a list of suspicious words. As seen here, the underlying patterns light up on their own, allowing the system to independently discover the mathematical characteristics of spam. By digesting an enormous volume of examples, the machine discovers its own rules, bypassing the limitations of traditional human programming. This automated learning process occurs in structured environments, like this server farm, moving through a strict 5-step cycle. Step 1 is collecting data. Gathering massive, high-quality datasets, like text documents, medical records, or traffic logs, provides the fuel for the entire process. In Step 2, engineers train the model. This diagram illustrates data feeding into a blank algorithm. Initially, the system is essentially guessing. Its internal connections are randomized, leading it to make constant mistakes. Step 3 is measuring performance. Engineers test the AI using completely unseen data to expose its predictive flaws and map out its error rate. Step 4 is improvement. The internal connections are mathematically adjusted based on those tests. This cycle repeats millions of times until the connections align. Step 5 is deployment. Only when this rigorous cycle yields consistently high accuracy is the hardened model finally released into the real world. An AI's intelligence is the result of a rigorous mathematical cycle of trial and error. Once an application reaches your smartphone, it's a common misconception that the AI is continuously learning and evolving with every single prompt you type into it. In reality, most deployed models are frozen. They only improve when engineers periodically take them offline to push them through a completely new, heavily curated training stage. Because its rules are derived entirely from historical training examples, the system's capabilities depend on what it consumed in the lab. This creates a strict requirement in AI engineering, represented in this diagram: garbage in, garbage out. If an AI is trained on biased or inaccurate data, it will confidently output biased and inaccurate predictions. Building a larger algorithm is a math problem, but ensuring the purity and accuracy of the training data is a much more difficult challenge. AI is a highly complex mirror, reflecting our own data back at us. Ultimately, the safety of these systems is determined by the quality of the information we feed them. If you could train a personal AI to handle one specific task for you, what would it be? Let me know in the comments.